Bardzo miło mi teraz zaprosić na scenę I would like to welcome Tobias Malbrecht z firmy Altair. Firma Altair z kolei jest takim dla nas bardzo też ciekawym i ważnym partnerem, który pomaga, jak już mamy przygotowane dane, mamy je dobrze opisane, to pomaga je dobrze przekształcić w analizy zaawansowane, no i wyciągnąć jak najwięcej takiej wartości biznesowej z tych danych. Sorry, I made it in Polish.
I didn't understand the word.
But you have to believe me, it was good.
Good, excellent. Great. Yeah, thank you so much. Thank you so much, Pavel. Yeah, my name is Tobias Malbrecht. I'm with Altair, and yeah, pleasure to be here. It's actually my first time being at this awesome event, and yeah, I've had the pleasure to talk about AI a little bit, right? What a surprise! And well, I do believe this this image that you painted, like the journey of the unknown, that's I think an excellent statement about the market as we see it today, right? That is because, well, there is undeniably a huge hype around AI, generative AI, right? Everybody's doing it. McKinsey is claiming it's like the fourth platform revolution after personal computing, the internet, cloud computing, social media, mobile computing, right? But what we find when we talk to our customers, well, we actually find that a lot of companies and people think about AI as just chatbots, right? And that's very unfortunate, basically, right? Why is that? Well, it's because AI is much more than really just chatbots. It feels like there's this really super powerful tool, but all it's really used for is like this very boring, mundane chatbot kind of thing, basically, right? But if you look at what AI, and especially generative AI, could be, and I'm sorry, it's very small in the slide, but here it basically shows all the aspects that you kind of can relate generative AI to. And if you look at this orange bubble there, that is basically text generation. And if you go to the model marketplace on Hugging Face, there are about like 60,000 of models just for text generation alone, so just for this little bubble over there. And well, about half of them can be used for chatbots, right? But that means that the other half and all the rest can potentially be used for something else. So there's really a lot of opportunity there. And what I would like to offer also in like light of the theme that you put this day under is really our opinion of what we believe generative AI will do to our market basically and to our industry, and that is data and analytics. And we actually believe that generative AI will change, well, basically everything. And we will basically go through three kind of examples of where we believe generative AI will really have an impact to our industry and how it will change the industry. So first of all, we believe that it will change the way how we do analytics entirely, basically. There will be a ton of new use cases, and you saw some of those in the mind map, basically. But it will also change how we currently do data analytics. It will accelerate a lot of things, and we even believe that it will replace a lot of the traditional machine learning that we do today. Second, it will accelerate the democratization of AI. So we try to give AI into the hands of many people as possible, basically, but there are still limits, right? And there will always be some kind of limits. But we believe that generative AI will drive the boundaries much further. And lastly, we believe that generative AI will help understanding data in a better form. And why is that? Well, basically, generative AI and knowledge graphs together are a fantastic tool, basically, that really try and succeed in turning data more into business insights that you are actually interested in beyond the raw data. So let's look at those three elements a little bit more in detail. Let's start with the disruption of analytics. There are three examples that I brought here. The first one is data quality. A generative AI can basically identify and fix data quality problems. Initially, you would not have guessed so. Well, why is that possible? Well, basically what generative AI models do is they don't just look at your data, right? What they also have is like what we call a world model, basically some understanding of the world already. And they can leverage that, that knowledge basically to make decisions about the data they see and the data they have in front of you. Second, data engineering, same story, right? There's lexical knowledge basically encoded in those Gen AI models, large language models, world models that can be used, well, to enrich data that you have with some of that lexical knowledge. And lastly, machine learning. Well, we also believe that Gen AI will replace a lot of the machine learning use cases and machine learning methodology basically. Why? Because it can do the kind of classification or regression or whatever with much less training data than actually a traditional machine learning approach could do. Let's look at one example a little bit more in depth. So let's call it outlier detection with generative AI. We have just a bit of sample data over here, quite simple, and we have a task. We want to find suspicious rows or outliers in that data set to remove it potentially, to, well, put the data into like action in some dashboard or wherever else, right? So, and if you look at this data here, just 3 rows basically. Now, how would a statistical, classical, traditional machine learning algorithm look at these data? It will basically go through all the data, every single line, and then reason with, or find some statistical elements in there to figure out, well, which row deviates a little bit from the rest, in a sense, okay? But if we look at the data, well, it's quite obvious that row number 2 looks a little bit suspicious, right? A software engineer with $45,000 US salary, living in Los Angeles and owning a Ferrari, potentially a little bit suspicious, right? And why can we do that? Well, we can do that because we have like a lot of understanding of the world. And that is exactly what a Gen AI model has, right? It has the same, maybe even a little bit more understanding of the world because it has seen more stuff in a sense, right? So what we could do is, well, we could ask a Gen AI model, hey, here you get some attributes of a person. Well, rate the plausibility of those attributes, right? Are those plausible to you? And maybe rate those on a scale from 1 to 10. And then just deliver the number. And this is exactly what we could do in a process like this. Here you see a little bit of an Altair RapidMiner process, basically, which loads the data, then sends it row by row to a Gen AI model like ChatGPT, and just sends over the data in this particular prompt. And then there is a result, basically, that we will just attach to this data set as a new plausibility column. And as we would guess, like the first row, very plausible, kind of a 10, second row, not as much, right? So this is just a very small example that should give you some insight of like how Gen AI will change analytics in general. And there are numerous other examples. So to summarize this a little bit, generative AI is much more than just chatbots. There are hundreds of thousands of new use cases, but it will also solve existing use cases. And it will do so even in a better way because it will need much less training data and data at hand. And then lastly, yeah, we will see basically a huge speed up due to Gen AI because of that ability. Second section, AI democratization. Well, first of all, let's look a little bit at how AI is being done from a user perspective today. There is basically a spectrum of what we call authoring modalities, ways how people interact with AI platforms to do something, to do AI effectively, right? There's for sure coding for the data experts. They code in things like Python or R or SAS code or something else. But then there's also visual workflows, which often work well for domain experts that may have expertise in the domain, but don't have as much experience basically in data science or machine learning or in coding in general. And then there's automated machine learning that also accelerates the experts, but is simple enough. It's often like wizard-based interfaces that will also enable business experts to do the job effectively and to use AI models and generative AI models. Now, how will all of those models be improved or those modalities be improved? Well, the answer is co-pilots, right? So basically, GenAI will be able to help in all of those modalities. As an example, take coding. So what we could do, for instance, to say to a copilot, as an example in our platform is, hey, write me some SAS code that creates a random data set of 1,000 rows and 20 variables and then runs a proc summary, right? And it may come up with something like this. Well, obviously I couldn't come up with this, right? But a developer could, but it takes a bit of time, right? And what this copilot mostly does is it accelerates that time to come up to first results, right? And the work of the user becomes more of a validation task than actually a development task. And with that, obviously, there's acceleration in the work. Second, you can do the same thing basically for visual workflows, just as we also have in RapidMiner. And let's say we are in a retail business and we just want to understand a simple analytics result and which of our stores has the most revenue, right? And this could be translated effectively by a Gen AI model into a simple visual workflow like that contains of a few steps. The first one would aggregate all the sales data grouped by the store. It would sort it in a descending way so that the store with the most revenue is on top. Then it would filter on that row and then would maybe just like shape the data set to select some column there. So again, the copilot obviously does, even though it's not a very complex process basically of figuring that out, it would simplify and accelerate the work of the user that the user would do. Now, summarizing that quickly, why will generative AI accelerate AI democratization? Again, it's about removing the burden for the users to learn how to use a tool. They can do it much faster because they already know kind of the paradigm with which they interact, which is their natural language. Second, that conversational interaction will improve all the modalities that we see, whether it's coding in a development environment, whether it's visual workflows, whether it's more automated approaches. Conversational interaction will improve all of those, simplify those, and accelerating the productivity of users. But it will also allow to bring up entirely new modalities that even simplify data analytics much more, and with that broaden analytics, developing machine learning models, developing AI to an even broader user base, which I think will ultimately be a good thing. And lastly, while the current focus of such co-pilots is on authoring, right? So developing code, developing workflows, we will definitely see approaches that span the entire AI lifecycle, basically, along the entire AI value chain. Think about something like ML operations, where you want to operate a machine learning model. So we will definitely see at some point generative AI assistants that will basically suggest a strategy to operate a model, when to swap it out, when performance is degrading. Strategies like that may also come from generative AI models. Coming to the third aspect, and here I would like to explain a little bit how Gen AI can help understand data better. And therefore, we need to step back just a tiny bit, and I need to introduce knowledge graphs. Well, what are knowledge graphs? Well, basically, they are induced by ontologies. And ontologies are kind of a semantic model for domains. Think of an example as the film industry, right? What do you have in the film industry? Well, you have certain classes in there, just as actors, films, directors. And those classes can have instances. So, as an example, an instance of the class actor could be Tom Hanks, right? Then you have relationships between those classes and those instances. For instance, acted in, like Tom Hanks acted in Forrest Gump, as an example, right? Or directed. And you can have attributes just as the name of an actor, again, Forrest Gump, year of release, whatever year of release Forrest Gump was released as the film, right? And now knowledge graphs knowledge graphs are basically real-world implementation that contain the ontology, but also contain data for that ontology, right? So as an example data point, one basically relation that could be, or one data point that could be part of the knowledge graph is Tom Hanks acted in Forrest Gump or Splash or what else, okay? So what are the benefits of knowledge graphs? Well, there are a few. First of all, they connect all the data from different sources, right? So basically, you ingest all your enterprise data into a knowledge graph, and then you have one way to access the data. So that also simplifies access to your data quite a bit. And it can be even quite complex, right? It can be both unstructured, it can be structured. There's simplification in accessing the data because you only access it through like one source of truth in a sense, right? And there's also kind of a semantic layer in a sense. So you don't like access like raw table artifacts or something like that. You access basically data in business terms. Give me all actors or show me all films in a sense, right? And it's not like select star from TS_film XYZ, right? So it's basically up-leveling the way how you interact with data. And the real benefit of knowledge graphs here is that it allows to effectively find very complex patterns in the data. Why is that? Well, because it's all in the data, and since it's a graph, you can traverse it quite well, in a sense, right? So you can basically go from one step through multiple hops to come up with a really complex answer that spans basically the entire knowledge graph. And you typically do that with graph query languages, but we will also see a little bit how we can potentially ease that in a second. Now, the final benefit of knowledge graph, and now here it comes back to Gen AI, thanks for bearing with me. Basically, knowledge graphs ground AI and large language models in context to increase the precision of their output. So they have kind of a symbiotic relationship in a sense, right? And we will see a little bit more how that works on the next slide. So here we have kind of an application of this. So let's assume down there we have all the, at the lowest level, at the bottom, we have all the data you have within an enterprise, right? Let's assume we are a manufacturing company, so there's engineering data in the design process, product lifecycle data. Then you have all the manufacturing data coming from IoT devices and your shop floor in the factories and so on. And then you have after-sales data like field reports, claims, and operations. And you can integrate all of those data into a single knowledge graph. And that also means that you can access all of these data within the single knowledge graph with a single paradigm. Again, typically a graph query language like Sparkle or GraphQL. But then where Gen AI comes in is, well, you could also translate basically natural language queries into those GraphQL queries, right? So there it's becoming kind of a co-pilot basically to access your knowledge graph. And I'm going to show you an example here of a product that we built, basically kind of a co-pilot for data exploration on top of a knowledge graph. This is here from a demo that we gave recently. So, and we could just ask like, hey, can you show me all the details of a specific movie? Kind of a simple question, also in terms of like a SQL query or something along those lines. And of course, it will give you the answer here, right? So titles, Space Odyssey, whatever. But we could also ask, list me all the actors who performed in this movie and also show some details about each actor. So going a few hops further in the graph, basically, right? And well, it does that, right? So it gives us the all the players and actors that played in this actual movie. But we could even ask questions like, hey, please compute the average age of these actors. So there are two things to note. One is we didn't give the movie name anymore, right? So we just said, hey, in this movie. And basically from the history of the conversation, the co-pilot was able to infer, well, it's still about the Space Odyssey kind of thing. well, obviously it's a chatbot again, after all, right? So it should remember that. But the other aspect is also interesting, right? The average age of the actors who performed in Space Odyssey is 93. And that's interesting, right? Because, well, the knowledge graph and the data does not have a concept of age. So in this data, there's just the date of birth for those actors. So how did it come up with that? Well, that's basically the connection to the GenAI model, right? Because the GenAI model knows that to compute the age, it would need to subtract basically the date where we are now from the date of birth, or the other way around, right? And then, well, it also knows how to compute the average, in a sense, right? So what to do. So, and there's the combination basically that makes this combination of knowledge graphs and generative AI so powerful. So how will generative AI help with data understanding? Well, first of all, knowledge graphs, right? Knowledge graphs allow semantic modeling of data and easy access to all data within an enterprise. Knowledge graphs provide context to GenAI to help them answer very specific questions. So basically what you can do is you can bring in data from knowledge graphs into GenAI again, so that it can reason also about your enterprise data, not just about the world, but about the very specific data that you have. Second, well, generative AI, again, can also further simplify accessing the data, right? Because we can build kind of a co-pilot interface to, well, access that data. And we just saw an example of that in the demo screenshots. So lastly, generative AI and knowledge graphs become kind of cornerstones of a new architecture that we are seeing and also are trying to drive, which is called the AI fabric. And really the objective of that AI fabric architecture is to turn raw, siloed data into pervasive business understanding. Well, how does that look like? So basically, we believe that what happens is, and how all those three themes basically come together, is through the advent of a new architecture, if you will, that's called the AI fabric, that basically brings together kind of a data store, the data fabric, and that contains knowledge graphs, but also like regular databases, ETL processes, and so on, with AI platforms. And AI platforms that obviously contains all the goodies of an AI platform, like all the coding, all the code optional development tools like visual workflows, that contains business intelligence as well as MLOps. And both come together to actually bring you more insight to your needs. And really, we believe that a lot of that will be driven by knowledge graphs, but predominantly also by generative AI. And with that, I hope that I gave you some hints of where we believe the market is going, and that it can maybe also hopefully remove some of the skepticism that we also heard in the beginning, but I think that's exactly why we're here for today. Thank you so much.
Thank you very much.